Imagine for a second that you're living 400 years ago. There are no calculators, there are no computers, there's not even electricity. But you're an astronomer, and you desperately need to calculate planetary orbits to understand the universe. Welcome to this explainer, where we're going to dive into how a simple mathematical trick completely revolutionized the speed of human discovery.
Okay, let's really put ourselves in their shoes. You need to multiply 8,472 by 5,839. What do? Today, you just pull out your phone. But back then, doing a massive calculation like this completely by hand could literally take you hours of tedious, mind-numbing work.
And that brings us to the big number problem. It wasn't just a minor inconvenience, it was a massive roadblock for science. Before the 17th century, navigators, engineers, and astronomers constantly wrestled with these giant numbers, and the stakes were incredibly high. A single calculation error in navigation didn't just mean a bad grade on a math test. It could mean a devastatingly lost ship at sea. The scientific revolution was essentially bottlenecked by the sheer time it took to do arithmetic. Humanity desperately needed a shortcut. Then, in 1614, a Scottish aristocrat named John Napier stepped onto the scene. After 25 years of relentless, painstaking work, Napier published a book detailing a brilliant hack. He gave us the logarithm. He actually coined the term from the Greek words logos, meaning proportion, and arithmos, meaning number. It was an ingenious operational tool with one incredibly ambitious goal. What if we could replace the agonizing process of complex multiplication with the much simpler, faster process of addition? So how exactly does this work? Let's get into the magic of addition.
The core mechanics of this trick are surprisingly elegant. It really just requires a slight shift in how we look at numbers. Instead of looking at the numbers themselves, we look at the exponents that create them. You see, a logarithm simply asks one fundamental question. What power must we raise our base number to in order to get our target number? Look at this example here. If our base is 10 and our target is 100, the logarithm is 2. Why? Because 10 to the power of 2 equals 100. It's essentially reverse engineering the exponent. You give the logarithm the result, and it tells you the exponent.
Now check this out. This foundational property is the actual mathematical magic trick that changed the world. It proves that the logarithm of a multiplied product is exactly equal to the sum of their individual logarithms. In plain English, multiplication transforms into addition. The hardest part of math suddenly becomes the easiest.
Let's see this brilliantly illustrated right here. Say you need to multiply 100 by 1,000. Instead of doing the long multiplication, you just find their logarithms. The base 10 log of 100 is 2, the log of 1,000 is 3. You just add them together. 2 plus 3 equals 5. And what number has a base 10 logarithm of 5? It's 100,000. By looking up these numbers in a table, adding the smaller numbers together, and looking up the result in reverse, human calculators save themselves hours of their lives.
This incredible shortcut quickly ushered in a completely new phase of history, the slide rule era. This seemingly simple shift completely transformed how humanity built the modern world. It took the concept out of dusty academic books and put it right into the hands of working engineers. Look at this evolution. We went from manual math taking hours to Napier's heavy tables, and then, in the 1620s, a man named William Audred had a brilliant idea. He put those logarithmic scales onto 2 sliding pieces of wood. You could literally just slide one piece against the other to add the scales. The slide rule was born. Suddenly, calculation times plummeted from hours down to mere minutes. For the next 350 years, the slide rule was the absolute standard tool for engineers everywhere. If you look at the greatest engineering feats of the 19th and 20th centuries, the first airplanes, complex suspension bridges, massive factories, they were all calculated using a slide rule. Even the Apollo space missions that successfully put human beings on the moon relied on engineers trained to use logarithmic slide rules. But wait, electronic calculators eventually came along in the 1970s, right? So are logarithms obsolete? Not at all. Today, they serve as the ultimate number compressor. Even though we don't necessarily need them to avoid manual multiplication anymore, notice how the logarithm neatly compresses rapidly multiplying colossal values into a highly manageable additive scale. As the real value grows multiplicatively, 10, 100, 1,000, 10,000, jumping by massive factors of 10, the logarithmic scale simply grows additively, 1, 2, 3, 4, 5. Actually, we use this in everyday language all the time. When we say someone makes a six-figure salary, we are using a primitive logarithmic scale. We're essentially saying the logarithm of their salary is between 5 and 6. It compresses a huge range of money into a simple single digit. Because of this unmatched compression power, we see logarithms in our world everywhere we look. They are secretly hiding behind the scenes of our daily lives, giving us a mathematical language to describe the absolute extremes of the natural world. We experience these scales constantly. When we measure the devastating magnitude of earthquakes on the Richter scale, we're using logarithms. A magnitude 6 is actually 10 times more powerful than a magnitude 5. Testing acidity with the pH scale, measuring sound in decibels, search algorithms routing the internet, all logarithms. Even our brains use them. When we listen to musical notes, the actual physical frequencies are multiplying, but our brains perceive the steps between notes additively. We literally hear music logarithmically. So ultimately, the logarithm isn't just some math formula you were forced to memorize in high school. It's a fundamental lens. It's a way to see patterns where numbers seem infinitely large. It tames the extreme, colossal scales of the universe into something our human brains can easily comprehend.
What started 400 years ago as a desperate mathematical trick to save astronomers from endless manual calculations now quietly runs our digital age. The code in your smartphones, your computers, your GPS, it all relies on this. And it all started with a simple, incredibly brilliant idea: turn multiplication into addition.
So, what does this mean for the next leap in human discovery? Are you ready to understand the math that truly runs the modern world? If you want to dive deeper into the hidden formulas all around us, make sure to subscribe to the Code of the Universe Explainer series, where we make the most complex math perfectly clear. Thanks for joining us, and keep exploring.